They were forgotten on purpose. 9 machines that changed the outcome of wars, saved thousands of lives, and then quietly disappeared from history books while slower, uglier, less effective weapons got the statues and the Hollywood films. One of them was flying stealth technology before stealth had a name. Another ended a war in 2 weeks by going where no tank was supposed to go. A third one got shot down so rarely that the Air Force tried to retire it, and then a war in Iraq made everyone shut up about that idea. 9 weapons, 9 stories. None of them are the ones you learned about in school. In August of 1943, 2 brothers received an official order from the German Air Ministry. The assignment was simple on paper and impossible in practice. Build an aircraft capable of 1,000 kilometers per hour with a range of 1,000 kilometers, carrying a bomb load of 1,000 kilograms. Most design bureaus looked at those numbers and declined to participate. The Horten brothers said yes. Walter and Reimar Horten had been working toward this moment for 12 years. Since 1931, when they built their first glider, the 2 brothers had been developing a concept that the aviation establishment considered somewhere between eccentric and insane. A flying wing. No fuselage, no tail. The wing itself generates all the lift, carries all the weight, and contains the crew. Less drag meant more speed and range from the same engine power. On paper, it worked perfectly. In practice, nobody had made it work yet. The first unpowered prototype lifted off in Göttingen on the 1st of March, 1944.
A year later, in February of 1945, the second prototype flew, this time with 2 Junkers Jumo turbojet engines, each producing 890 kilograms of thrust. During flight tests, the aircraft reached 795 kilometers per hour. That was faster than any Allied production fighter in service at the time. The projected top speed of the production version was 970 kilometers per hour. In March of 1945, Hermann Göring added the aircraft to the emergency fighter program. 2 months later, American forces captured the factory at Friedrichsroda. Serial production never began. The captured third prototype was disassembled and shipped to the United States. In 1958, it was transferred to the National Air and Space Museum in Washington, where it remains today. In 2008, Northrop Grumman, the company that built the modern B-2 stealth bomber, constructed a full-scale replica of the Horten aircraft and ran it through radar testing. The result? The aircraft was detectable by British radar systems of the era at roughly 80% of the range at which a standard Messerschmitt would have been spotted. That is a modest improvement in radar cross-section, but combined with a speed advantage that left interceptors almost no time to react, the operational picture looks very different. The production version, by calculation, could have reached the British coast faster than British interceptors could have climbed to intercept altitude. Reimar Horten claimed in 1983 that he had deliberately mixed charcoal powder into the adhesive used during airframe construction, specifically to absorb radar signals.
No documentary evidence of this has survived in military archives. Whether it was intentional stealth engineering or an accidental side effect of the wooden construction, the radar signature data from the Northrop Grumman tests is real. The Horten brothers built the stealth aircraft in 1945. Nobody remembers their names. In 1938, engineers at the British firm de Havilland walked into the Air Ministry with a proposal that the military establishment found somewhere between naive and offensive. They wanted to build a high-speed bomber out of wood. No defensive guns, 2-man crew. The logic: if the aircraft was fast enough, it would not need to fight its way through. It would simply outrun anything sent after it. The Air Ministry rejected the proposal.
They believed an unarmed bomber could not survive in combat. De Havilland continued development on their own money. The prototype flew on the 25th of November 1940. Serial production began in October of 1941. The airframe was a 3-layer sandwich, 2 outer sheets of plywood with a core of balsa wood reinforced with spruce covered in fabric. The engines and control surfaces were metal. Everything else was timber. That wooden construction delivered 2 advantages that no one at the Air Ministry had anticipated. First, weight. The aircraft was dramatically lighter than comparable all-metal designs, which translated directly into speed and altitude performance. Cruising speed at 11,000 meters was between 640 and 675 kilometers per hour. At that altitude and that speed, the Mosquito was effectively unreachable by standard German fighters. Only the jet-powered Messerschmitt Me-262 could intercept it reliably, and by the end of the war, operational Me-262 units were measured in dozens, not hundreds. Second, radar signature. Luftwaffe radar systems had serious difficulty detecting the approaching Mosquito. An aircraft that bureaucrats had dismissed as impractical was quietly invisible to the technology meant to stop it.
The loss rate tells the story with brutal clarity. 16 aircraft lost per 1,000 sorties. That was the lowest figure in the entire RAF Bomber Command. On the 30th of January 1943, the 10th anniversary of Hitler's rise to power, Mosquitoes struck a Berlin radio station in the middle of a live broadcast of a speech by Goering. The transmission cut out. The speech was never finished. On the 18th of February 1944, 18 Mosquitoes breached the walls of Amiens prison in Operation Jericho, freeing French resistance members who had been sentenced to execution. 7,780 aircraft were built across all variants. When the project was finally approved in 1939, an Air Ministry official wrote in an internal memo, "We are going to get a wooden aircraft that will be faster than the Spitfire." He was right. And somehow, this aircraft is not the one that ended up on the posters.
The dive bomber does not exist anymore. Guided missiles, precision munitions, and multi-role strike aircraft made it obsolete. The last specialized dive bombers were retired in the 1950s. The class of aircraft that altered the course of the Second World War on the Pacific Theater lasted less than 20 years from first operational use to final retirement. The concept originated in the United States. In the early 1930s, a German pilot named Ernst Udet watched a Curtiss biplane drop bombs in a steep dive at an American air show. The accuracy he witnessed was so far beyond what horizontal bombers could achieve that he arranged the purchase of 2 aircraft for evaluation in Germany. That purchase directly triggered the development program that produced the Junkers 87, the aircraft known as the Stuka. German planners immediately grasped the core advantage. A dive bomber released its payload at an angle approaching 90 degrees to the target. The accuracy was not marginally better than level bombing. It was a different category entirely. The Stuka became the primary instrument of the blitzkrieg across Poland, France, and the Balkans. But the defining moment of the dive bomber happened over water. On the 4th of June, 1942, 54 American Douglas SBD Dauntless dive bombers from the carriers Enterprise and Yorktown attacked the Japanese carrier strike force near Midway Atoll. In 6 minutes, 3 Japanese carriers, Akagi, Kaga, and Soryu, were engulfed in fires beyond control. Later that same day, a 4th carrier, Hiryu, was sunk. Japan lost 4 fleet carriers, 248 aircraft, and more than 2,500 experienced aircrew and maintenance specialists. Japanese industry could not replace those losses before the end of the war.
The outcome of the Pacific campaign shifted in 6 minutes. 5,936 Dauntless aircraft were built across all variants. The last Stuka rolled off the production line in August of 1944. The aircraft that broke the back of Japanese naval power at Midway was already being phased out of frontline service by then. A weapon that changed the trajectory of a world war, and almost no one who wasn't there remembers it. In 1964, the Soviet Union fielded an anti-aircraft system that barely registered outside specialist military publications. 4 23mm barrels on a tracked chassis, radar fire control, a rate of fire up to 3,400 rounds per minute. The vehicle was named after the Shilka River, a left tributary of the Amur. Before the ZSU-23-4, small-caliber anti-aircraft artillery was essentially a curtain-fire weapon. You put enough steel in the air and hoped something collided with the target. The volume of fire was never sufficient for reliable engagement of high-speed aircraft. The designers of the Shilka were the first to solve the problem as a system, combining high rate of fire, radar target tracking, and a self-propelled chassis in a single integrated platform. This created a mobile air defense shield capable of keeping pace with armored columns and infantry formations on the move. In October of 1973, Egyptian and Syrian forces attacked Israeli positions in what became known as the Yom Kippur War. Israeli aviation encountered something it had not prepared for. The Shilka systems created such dense fire coverage at low altitudes that pilots were forced to climb directly into the engagement envelope of surface-to-air missile batteries. According to Western sources, between 30 and 43% of Israeli aircraft losses in that war were attributable to Shilka fire. Israeli forces captured one example and immediately transferred it to NATO specialists for analysis. American intelligence ran a separate covert operation in the early 1980s to obtain a second unit. The operation involved the brothers of Romanian President Nicolae Ceausescu. The Shilka remained in serial production until 1982. In Afghanistan, Mujahideen fighters who had no air force of their own and therefore faced the Shilka purely as a ground support weapon, called it Shaitan Arba, Devil's Chariot. They feared it more than any other Soviet weapon in that conflict. A vehicle that reshaped air warfare doctrine on 3 continents, named after a river almost nobody outside Russia has ever heard of. In 1991, during Operation Desert Storm, the United States Air Force was actively planning to retire one of its aircraft. It was subsonic. It was slow. It was ungainly. Pilots called it the Warthog. The Air Force would have preferred to replace it with an F-16 in a ground attack configuration. The war in Iraq ended that conversation. 144 A-10 Thunderbolt aircraft flew 8,100 sorties and destroyed more than 1,000 Iraqi tanks, more than any other aircraft type in the U.S. Air Force inventory. 7 aircraft were lost. That is, 1 loss per 1,350 sorties. 1 Thunderbolt returned to base with wing damage so severe that the ground technician on record said no other aircraft would have made it back with that. The story of this aircraft begins with the lessons of Vietnam. When Soviets supplied heavy machine guns and anti-aircraft systems, including the Shilka, began appearing in large numbers against American strike aircraft in the jungle, it became clear that light piston engine and early jet aircraft were too fragile for the environment. In 1966, the U.S. Air Force issued the AX program, Experimental Attack Aircraft. The requirement went to 21 manufacturers. The core specification? Destroy Soviet tanks on the European theater of operations while flying through dense anti-aircraft fire. On the 10th of May, 1972,
the Fairchild Republic prototype flew for the first time. It defeated the competing Northrop design. Production aircraft began entering service in March of 1977.
The entire design was built around a single weapon, a 7-barrel, 30mm GAU-8 Avenger rotary cannon capable of firing up to 1,800 rounds per minute with armor-piercing depleted uranium ammunition. The cannon was so heavy that the nose landing gear had to be offset from the aircraft's centerline. There was no other way to fit it. The pilot sits inside a titanium bathtub with walls up to 38mm thick. The aircraft can fly on one engine. It can fly with a damaged hydraulic system. It can fly with part of the wing structurally compromised. After Desert Storm, the retirement discussions stopped permanently. As of 2025, approximately 280 aircraft remain in service. The ugly, slow, ungainly warthog that nobody wanted has now been in continuous service for nearly 50 years. The torpedo boat is gone. The last specialized examples were retired in the 1970s and 80s, replaced by missile boats, helicopters, and submarines. As a weapons platform, it had a lifespan of roughly 60 years. During 2 world wars, it repeatedly decided the outcome of engagements that battleships and cruisers could not resolve. The first torpedo boats appeared in the early 20th century, small wooden vessels with gasoline engines and torpedo tubes. Their primary weapon was not firepower, but speed and low visibility. They operated at night, attacked from darkness, and were gone before the target could mount an effective response. On the Pacific theater of the Second World War, American PT boats played a role entirely out of proportion to their physical size. After Pearl Harbor, when American forces in the Philippines had lost their air cover and their major surface vessels, the only remaining combat force was a torpedo boat squadron under the command of Lieutenant John Bulkley. It was the only offensive naval capability left in the theater for months. In 1943, future United States President John Kennedy served aboard PT-109 near the Solomon Islands. His boat was rammed and cut in half by the Japanese destroyer Amagiri. Kennedy led the survivors through 4 days in open water before reaching safety. The story became part of American political mythology, but it began on a torpedo boat. Off Guadalcanal, between 1942 and 1943, PT boats intercepted the Japanese night resupply convoys known as the Tokyo Express. On the 7th of December 1942, 5 torpedo boats attacked a Japanese convoy of 11 destroyers off Cape Esperance, torpedoed the flagship, and forced the entire convoy to reverse course. The threat posed by torpedo boats operating around Guadalcanal compelled Japanese command to shift resupply operations from destroyers to submarines. Submarines had a fraction of the cargo capacity. The volume of supplies reaching the garrison dropped sharply. That decision accelerated the collapse of the Japanese position on Guadalcanal. A force of small wooden boats changed the logistics of an island campaign that shaped the entire Pacific War. When Hollywood began filming the movie about Kennedy's PT-109 in 1963, the production team could not find a single operational torpedo boat anywhere in the world. Not one. The class had been retired so completely that they had to build a replica from scratch. In 1951, the Soviet Union fielded a light tank that weighed 14 tons and drew very little attention from Western analysts. The armor was thin. The 76mm gun was modest by post-war standards. The vehicle looked like a compromise, something built to specifications that traded combat power for a different capability entirely. That capability was water. The PT-76 could swim. A box-section hull with a sharpened bow and a hydrojet propulsion system
allowed the vehicle to move through water at over 10 kilometers per hour. During trials in 1951, PT-76 tanks crossed the Kerch Strait under their own power, a water crossing of nearly 15 kilometers between Crimea and the Taman Peninsula. No other production tank in the world could do this. The vehicle was built for a specific operational purpose: cross water obstacles at speed, seize a bridgehead, and hold it until heavier forces arrived. In river deltas, in marshland, in coastal terrain where a conventional tank would immediately become immobile, the PT-76 was at home. This capability decided the outcome of the Bangladesh Liberation War in December of 1971. The Ganges Delta is one of the most fragmented water environments on Earth. Pakistani forces defending East Bengal calculated that the rivers and swamps would serve as natural defensive barriers. Indian PT-76 tanks crossed water obstacles at locations where Pakistani commanders had not positioned defenses, because those locations were not supposed to be crossable by armored vehicles. On the 9th of December, a company of tanks reached the port docks at Chandpur and used direct fire to sink 3 river gunboats carrying 450 soldiers.
Over 2 weeks of fighting, Indian PT-76 crews destroyed 66 Pakistani Chaffee light tanks. Pakistan lost essentially its entire armored force on the Eastern Front. Israeli forces captured several PT-76 tanks during Middle Eastern conflicts and evaluated them so favorably that they were incorporated into Israeli Army service with American machine guns and new radio equipment installed. 3,039 vehicles were produced across all variants between 1951 and 1967. A tank that could swim ended a war. It has no monument anywhere. In 1988, the Soviet Baltic Fleet received a vessel that did not fit any standard classification. On paper, it was a small landing ship. In practice, it was the largest air cushion craft ever built. Displacement, 555 tons. Length, 57.5 meters. Beam, 25.5 meters. 5 gas turbine engines producing a combined 50,000 horsepower generate the air cushion and drive the craft to 70 knots, nearly 130 kilometers per hour. On board, 3 main battle tanks with crews, or 10 armored personnel carriers with 140 soldiers. The Zubr was developed at the Almaz Design Bureau in Leningrad under a 1978 requirement as the successor to earlier Soviet air cushion landing craft. The design brief was straightforward and ambitious. Create a platform that could land forces on coastline that conventional landing ships could not access. Conventional amphibious vessels are limited to gently sloping beaches with firm bottoms. That describes roughly 17% of the world's coastline. The Zubr can approach 70% of it. The craft can exit the water onto marshland, pass over minefields without triggering pressure mines, cross ditches and field fortifications, and land troops directly inside the defensive depth rather than at the water's edge. Underwater mines are irrelevant to a vessel riding on a cushion of air. 15 Zubr craft were built. After the Soviet dissolution, they were divided between Russia and Ukraine. The Zubr holds a distinction unique among Russian weapons systems. It is the only Russian military platform ever purchased by a NATO member state. Greece acquired 4 vessels. 4 additional craft were sold to the People's Republic of China. As of 2019, 2 Zubr craft remained in service with the Russian Baltic Fleet. A vessel that can go where no other warship can go, move faster than most naval patrol boats, and deliver a tank company directly onto an unprepared shore. And it is remembered mainly by the sailors who served on it. On the 6th of June, 1944,
156,000 Allied soldiers landed on the beaches of Normandy. Operation Overlord remains the largest amphibious military operation in recorded history. Behind that figure sits a question that almost no one asks. What exactly did they arrive on? The answer, in significant part, is the landing ship tank. Soldiers called them big, slow targets. The nickname was accurate in both halves. The concept originated in 1941 from a British requirement for a vessel that could transport tanks directly from American factories to a hostile shore without any intermediate transfer. The defining feature was an opening bow with a ramp, allowing vehicles to drive off under their own power directly onto the beach. Length approximately 100 meters. Draft at the bow, when loaded, approximately 1.5 meters. The first landing ship tank vessels were completed in 1942. By the end of the war, the Allied fleet included 1,152 of these ships from American yards alone. They participated in every major amphibious operation of the Second World War: North Africa, Sicily, Italy, Normandy, and dozens of Pacific island landings. At Normandy, they discharged tanks, artillery, and trucks directly onto Omaha, Utah, Gold, Juneau, and Sword beaches. Without them, the operation was physically impossible. No other vessel type could deliver armored equipment onto a beach in the required quantities. The math was simple and absolute. Without the landing ship tank, there is no Normandy landing. In the Pacific, these ships made the island-hopping campaign executable. Each successive island base brought American forces closer to Japan. The logistics chain that made this movement possible ran through the flat-bottomed holds of the landing ship tank. The class continued in service through Korea and Vietnam, was supplied to dozens of Allied nations, and was eventually superseded by amphibious assault ships with flight decks and well docks for landing craft. The last American landing ship tank vessels were decommissioned in 1994. 9 weapons, all of them real, all of them consequential beyond what any reasonable account of their specification would suggest. None of them are the weapons that get the documentaries. If any of these histories landed differently for you than you expected, if one of these machines deserves more than a footnote, leave that name in the comments. The channel exists because of those conversations. Subscribe if you want more of them. And if this was worth your time, a like costs nothing, and it means everything for whether the next video reaches someone who should see it.